all are fine. So in this video we will discuss about chemical properties of the metals. In the previous video we had already discussed about the physical property of the metals and non-metals, and now we will discuss about the chemical properties of the metal. So we will learn about the chemical properties of the metal in the flowing section. Here is the section is given. For this, collect the samples of the flowing metal: ammonium, copper, iron, lead, magnesium, and zinc, sodium. Okay. Now here is what happens when metal is burned into air. The first one is that what happens if the metal is burned into air. So you have seen in the activity 3.8. Here is given that about the activity. Almost all metal combine with oxygen to form metal oxide. It means almost all the metal that combines with oxygen to form metal oxide. So here is given that the metal plus oxygen is equal to metal oxide. For example, when copper is heated in air, it combines with oxygen and to form copper. This one, a black oxide. Okay. This one is example, these two are examples. Let's call the most of the metal oxide are insoluble in water, and most of the metals oxide are also insoluble in water, but some of them these dissolve in water in form of alkalis. It means in the form of alkalis they dissolve into a water. Now sodium oxide and the potassium dissolve in the water to produce alkalis as follows. Okay. We have observed in here about the activity. Different metals show different reactivities towards oxygen. It means different metals shows the different reactivities towards the metal. Okay, towards oxygen. Now metals such as potassium, sodium that react so vigorously that they catch fire if kept in the open fire. It means the metals such as potassium and sodium, they react so it catch fire if it kept in the open. Okay. Now hence to protect them and to prevent the accidental fire, they are kept immersed in a kerosene oil. It means they are immersed in a kerosene oil because when they come in the contact of the air, okay, they catch fire. Okay, so just because they are kept immersed in a kerosene oil. At ordinary temperature, and the surface of the metal such as magnesium, ammonium, zinc, and lead are covered with a thin layer of oxide. Okay, these are the surfaces of the metal which are covered with a thin layer of the oxide. Now the protective oxide layer prevents the metal from further oxidation. It means magnesium that are covered from the protective oxide, that this protective oxide layer prevent the metal from further oxidation. It means this helps to prevent the further oxidation. Iron does not burn on heating, but iron filling burns vigorously when sprinkled in the flame of the burner. It means iron doesn't burn, but iron filling burns vigorously when they is sprinkled into a flame or a frame of the burner. Okay. Copper does not burn, but hot metal is coated with a black colored layer of copper. Okay, copper cupric oxide. Okay, it means the copper doesn't burn, but the hot metal that is coated with the black colored layer of the cupric oxide. Okay, so silver and gold do not react with the oxygen at high temperature. It means at the high temperature silver and gold don't react. Okay, after that here is given. After the performing, here is about the activity. The reaction of magnesium is less by which all are about the activity. Okay, does not help to decide the activity. Do you know? Anodizing is a process of forming a thick oxide layer of aluminum. It means anodizing. What is anodizing? It is a process of forming a thick oxide layer of aluminum. It means to forming a thick oxide layer of aluminum, anodizing process is used. After that, aluminum develops a thin oxide layer when exposed to air. It means aluminum develops a thin oxide layer when it is exposed to air. This aluminum oxide coat makes a resistant to further corrosion. Okay, it means the aluminum oxide coat makes it resistant to further corrosion. Okay, the resistance can be improved further by making the oxide layer thicker. It means this can be improved when the oxide layer by making the oxide layer thick. After that, here is given that during anodizing, a clean aluminum particle is made the anode and the electrolyzed with dilute sulfuric acid. It means during the anodizing process, a clean aluminum article is made the anode and is also electrolyzed with the dilute sulfuric acid. The oxygen gas involved at the anode reacts with the aluminum to make a thicker protective oxide layer. It means the oxygen that involved at the anode reacts with the aluminum to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminum particles. This type of oxide layer can be dyed easily to give aluminum particles an attractive finish. Okay, so these are the, here is given the point that is you have to know. Metal react with water and produce a metal oxide. So this is about the what happens when the metal reacts with the air. And the second thing is that what happens when the metal reacts with water. Okay. So let's see that what happens if the metal is react by the water. So metal react with water and produce a metal oxide and hydrogen too. Okay. It means if the metal react with the water, then it produces a metal oxide and hydrogen gas. Metal oxide that are soluble in water dissolve it into a further form metal hydroxide. It means that those type of metal that are soluble in water, they dissolve further and it forms the metal hydroxide. But all metal do not react with water. Okay, only few metals that react with the water. Metal like potassium and sodium react violently with the cold water. It means there is a two cases, like in the case of potassium and sodium they react with the cold water, and in case of sodium and potassium the reaction is so violent and the exothermic that involves the hydrogen immediately catches fire. It means in the case of sodium and potassium the reaction is so violent and also exothermic. Okay, so that involves the hydrogen immediately catches the fire. Okay, so the reaction of calcium, here is next one, that is the reaction of calcium with is less violent. It means this type of is less violent than the sodium and the potassium. The heat involved is not sufficient for the hydrogen to catch fire. It means in the potassium and the sodium there is a heat. Exothermic that involved the violent and also the heat involved is sufficient for the hydrogen to catch fire. But in this case, in the case of calcium, when it reacts with water, it is less violent than the sodium and the potassium, and also heat involved, but is not sufficient for the hydrogen to catch fire. This one is the reaction here. Now the calcium starts floating because the bubbles of hydrogen form stick to the surface of the metal. Now the calcium is start floating because the bubbles of the hydrogen form the sticks to the surface of the metal. Magnesium does not react with the cold water. Okay, it reacts with the hot water. Magnesium react with the hot water, sodium potassium react with the cold water. To form magnesium hydroxide and hydrogen, it starts floating due to the bubbles of hydrogen gas sticking into the surface, and calcium is also start floating just because the bubbles of hydrogen stick to the surface of the metal. Now the metal like aluminum, iron, zinc do not react either with the cold or a hot water. It means here is given that some metals only but all metal do not react with water. So here are the examples that metal like aluminum, iron, zinc, they do not react either with cold or a hot water, but they react with a steam to form the metal oxide and hydrogen. But they are only react but they react with the steam to form the metal oxide and hydrogen. Metals such as lead, copper and silver do not react with water at all. It means this metal will not react with water at all. Now what happens when the metal react with acid? First of all, we have read about what happens when the metal react with air. Second one is that what happens when the metal react with water. And the third point is that what happens when the metal react with acid. You have already learned that the metal react with acid to give a salt acid hydrogen gas. Metal plus dilute acid gives the salt plus hydrogen. But all metal react in the same manner. Let's find out. Write the equation of the magnesium. Hydrogen gas is not involved when the metal react with the nitric acid. It means hydrogen gas is not involved when it react with the nitric acid. It is because SNO3 is a strong oxidizing agent and this is about the reaction. Okay, you have this is the main point, that is aqua regia. This is a Latin for the royal water. Okay, now aqua regia is a freshly paired mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. It can dissolve gold even through neither of these acids can do alone. Aqua regia is a highly corrosive forming liquid. It is one of the few reagents that is able to dissolve gold and platinum. It means this is the most thing that dissolves the gold and the platinum. How do metal react with solution of other metal salt? Reactive metal can displace less reactive metal from their compounds in the solution to molten. Now we have seen in the previous section that all metals are not equally reactive. Here in the activity that is given, we check that the reactivity of various metals with oxygen, water and acid, but all metals do not react with these reagents. So we were not able to put all the metal samples we had collected in decreasing order. So their reactivity, displacement, chapter 1 reactivity. Here is given that all metal do not react with these reagents. So they were not able to put all the metal sample that we have collected in a decreasing order. Okay, here is a series is given, that is reactivity series. The reactivity series is a list of metal arranged in the order of their decreasing activities. Okay. This is a list of a metal that is arranged in the order of that in the decreasing activity. After performing displacement experiment, the flowing series. So here is given first one that most reactive, after that the reactive decreasing, and this one is a least reactive. Now here are some questions given. Now next one is how do metal and non-metal react. Okay, this is our next topic, and we will discuss this topic in the next video. And after that we have to read about the properties of the ionic compound, okay. Now the occurrence of metals. Okay, so extraction of metal. The occurrence of metal, there is extraction of metal, enrichment of ores, extracting metals low in activity series. After that, extracting metal in the middle of the activity series. Extracting metal towards the top of the activity. After that, there is a refining of metal, corrosion, then prevention of corrosion. In the previous chapter we had already discussed about in the chapter 1, okay, rancidity and the corrosion. Again, the prevention of the corrosion, the wonder of the ancient. And after that our chapter ends. Okay. So I hope you understand whole the video about the chemical properties of the metal. In the previous video we had already discussed about the physical property of the metal and the non-metal also. And in this video we had discussed about the chemical properties of the metals. Okay. So in this we have seen that what happens when the metal is react with air. After that what happens when the metal is react with water, and after that we will read. We have read about that there are two examples are here, that is so in the case of sodium and potassium they are so violent, so and they are so exothermic, and they involve hydrogen to catch fire immediately. After that what happens when metal reacts with acids, and what happen how do the metal react with solution of other metal salt. Okay, so these are the topics that we have, and the last one is that is the reactivity series. Okay, so these are the topics that we have discussed in this video, and in the next video we will discuss about that how do metals and non-metal react. So in here we will read about that in the above activity you show the reaction of metal with a number of reasons. Okay, here is some overview is given about the previous sections. Now okay, so I hope you understand the whole video. That's all for today. Thank you very much.